Hey, science fans! Bill Nye here, and today, we're about to embark on a fascinating journey into the world beneath our feet. Get ready to discover the building blocks of our planet. Today, we're diving into the world of minerals, the special ingredients that make up rocks, and, ultimately, our planet. Minerals are everywhere, and they play a much bigger role in our lives than you might think. So, what exactly is a mineral? To be a mineral, a substance must be a naturally occurring solid with a specific crystal structure. That means it forms in nature, isn't made by humans, and its atoms are arranged in a repeating pattern, giving it a unique shape and properties. Think of minerals as Lego bricks, each with its own unique repeating atomic pattern. Just like you can build all sorts of creations with Lego, nature builds rocks using different combinations of minerals. When you pick up a rock, you're holding a mix of minerals, like granite, which contains quartz, feldspar, and mica. Each mineral adds its own color, texture, and strength to the rock, making every rock a unique combination. The Earth's crust is packed with thousands of minerals, formed over millions of years by heat, pressure, and chemistry. These natural processes shape the minerals, creating everything from sparkling crystals to tough, durable stones. From the salt on your fries to the graphite in your pencil, minerals are everywhere. They're in the food you eat, the tools you use, and even the technology you rely on every day. Some, like quartz, are common and found all over the world. Others are rare and valuable, like dazzling gemstones or precious metals. These rare minerals are often sought after for their beauty and unique properties. We mine minerals to make everything from cars to computers, smartphones, and even the batteries that power our devices. Without minerals, modern life as we know it wouldn't exist. Ores are rocks with enough useful minerals to make mining worthwhile. These ores are processed to extract metals and other materials that are essential for industry and technology. Minerals aren't just pretty, they're the foundation of our technology and our future. Every electronic device, every building, and every vehicle depends on minerals in some way. So next time you see a rock, remember, it's a piece of planetary history, a record of Earth's incredible processes, and the start of every scientific breakthrough. Who knows? The next rock you pick up could inspire the next big discovery in science. Let's zoom in on a special group: rare earth elements. Despite the name, many rare earths are more common than gold or silver. The term rare earth comes from history. Early chemists found them hard to separate, not because they were scarce. The real challenge is that rare earths are spread thinly throughout the earth, rarely concentrated in big deposits. Instead of nuggets, they're tiny amounts mixed in with other minerals. To get enough, we have to process huge amounts of rock. That's why finding a good source is tough. Only a few places have enough rare earths in one spot to make mining worthwhile. So, the rare in rare earths is really about finding them in useful concentrations. That's the real story behind the name. Meet the rare earth elements, a group of 17 elements including the lanthanides, scandium, and yttrium. Their names sound sci-fi, but their powers are real. Neodymium makes super strong magnets, europium lights up screens, and erbium boosts internet signals. Beyond rare earths, there's a bigger club: critical minerals. These are materials essential for technology and security, but with risky supplies. Lithium and cobalt power batteries in phones and electric cars. Graphite, platinum group metals, gallium and indium are vital for electronics and clean energy. What makes a mineral critical? It's both essential and hard to get. If a mineral is vital for tech and only comes from a few places, it's critical. These aren't just rocks. They're the strategic ingredients of our high-tech world. Our future depends on them. So, where do we actually find these minerals that power our modern world? The answer is both simple and complex. These elements are hidden in the Earth's crust, scattered in deposits that are often remote, hard to reach, and sometimes in places you might not expect. While rare earths and other critical minerals are technically found all over the globe, large, concentrated, and economically viable deposits are surprisingly rare. Most are located in isolated or challenging environments, making extraction difficult and expensive. Right now, China leads the world in rare earth production, supplying the vast majority of the global market. Their advanced mining and processing infrastructure gives them a huge advantage, and many countries depend on China for these essential materials. This dominance has made other countries increasingly nervous about potential supply disruptions, especially as demand for these minerals grows in technology, defense, and renewable energy sectors. As a result, nations like the US, Australia, Canada, Brazil, Vietnam, and India are now ramping up their own exploration and mining efforts, hoping to secure a more stable and independent supply chain for these critical resources. To find new deposits, geologists use a combination of high-tech tools and old-fashioned fieldwork. They analyze satellite imagery, conduct magnetic and gravity surveys, and spend weeks or months in the field examining rock samples for signs of valuable minerals. Once a promising site is identified, teams drill deep into the earth to extract core samples. These samples are carefully analyzed in labs to determine if the deposit is rich enough to justify the enormous investment required for mining. But the search isn't limited to land. Scientists are now exploring the ocean floor, where mineral-rich nodules and underwater deposits could hold the key to future supplies. This new frontier is both exciting and daunting. Mining the deep sea brings a host of new engineering and environmental challenges, from building machines that can operate under extreme pressure to protecting fragile marine ecosystems from harm. The global hunt for critical minerals has become a high-stakes treasure hunt, with countries and companies racing to discover, claim, and develop new sources before their competitors do. The search is on, everywhere. From the deepest mines to the ocean floor, the world is in a race to secure the elements that will shape our future. Take a look at your smartphone. You might be surprised to learn that you're carrying rare earths and critical minerals in your pocket right now. These tiny elements are essential to the devices we use every day, often without us even realizing it. The brilliant, vivid colors on your phone's screen. That's thanks to rare earth elements like europium and terbium, which help create the reds and greens that make images pop. Without them, our screens would look dull and lifeless. The satisfying buzz you feel when you get a notification. That's made possible by neodymium magnets inside the vibration motor. These powerful magnets are small but mighty, and they're found in almost every modern phone. Even the smooth, scratch-resistant glass on your device owes its clarity to cerium oxide, which is used to polish and perfect the surface during manufacturing. It's not just your phone. Your computer's hard drive and your headphones also rely on rare earth magnets to store data and deliver crisp sound. These minerals are at the heart of our digital lives. Thanks to these elements, our gadgets have become smaller, lighter, and more powerful than ever before. Imagine carrying around a phone the size of a brick. Without rare earths, that might still be our reality. Modern cars are packed with advanced sensors, electric motors, and safety features, all powered by rare earths. From automatic braking to navigation, these minerals are driving innovation on the road. Electric vehicles in particular depend even more on these minerals. Their powerful motors and high-capacity batteries wouldn't be possible without a steady supply of critical elements. But the impact goes far beyond gadgets and cars. Critical minerals are essential in MRI machines for medical imaging, in jet engines for air travel, and in communication equipment that keeps us connected worldwide. They're even used in oil refining to produce cleaner fuels, and in stadium lights that illuminate our favorite sporting events. From life-saving medical equipment to airplanes and public transportation, these minerals are woven into the fabric of our daily lives, often in ways we never see. They truly are the hidden powerhouses of modern life, quietly enabling the technology and conveniences we depend on. Without these critical minerals, our world would look and function very differently. Imagine a life without smartphones, fast computers, or efficient transportation. So next time you use your favorite device, remember the unsung heroes behind the scenes. Rare earths and critical minerals powering the modern world. The green energy revolution depends on rare earths and critical minerals. Wind turbines use massive neodymium magnets. One turbine can contain over 600 kilograms. To power our cities with wind, we'll need thousands of turbines and tons of these minerals. Solar panels, especially high-efficiency ones, use tellurium, indium, and gallium to convert sunlight into electricity. As we improve solar tech, the demand for these minerals grows. Clean energy isn't just about wind and sun, it's about advanced materials. Storing green energy requires huge batteries powered by lithium, cobalt, nickel, and manganese. These minerals are the backbone of electric vehicles and grid-scale batteries. As the world goes electric, demand for battery minerals is skyrocketing. Building a clean energy future means securing these essential building blocks. Our green future is built on critical minerals. Because these minerals are vital for everything from phones to wind turbines, countries are getting strategic. For years, the world relied on China for rare earths, giving China control over supply and prices. A 2010 export halt sent shockwaves through global industries and woke up governments worldwide. Now nations are racing to secure their own supplies and diversify sources. This means investing in mining projects across the globe and building new supply chains. Governments are streamlining permits and partnering with allies to stabilize supply. It's not just about mining, the whole supply chain matters from processing to manufacturing. China has dominated these steps, but others are catching up fast. The race is on to build independent, resilient supply chains. It's a global chess game for the minerals of the future. Mining is tough on the environment, so what else can we do? Reduce, reuse, and recycle. Old electronics are urban mines, packed with valuable minerals. Recycling them is tricky. Phones contain dozens of materials fused together. Engineers are developing better ways to recover these elements from e-waste. A strong recycling industry could supply critical minerals right from our cities. We can also design products to last longer and be easier to repair or recycle. Companies are rethinking design to make recycling simpler and more effective. Scientists are searching for new materials to replace rare earths in magnets and batteries. By recycling, redesigning, and innovating, we can build a more sustainable, high-tech world. The future is circular and scientific. So, what's the big takeaway? Rare earths and critical minerals are the invisible foundation of our modern world. Without them, our tech, energy, and communications would be unrecognizable. They connect countries, industries, and people everywhere. The challenge: securing a stable, ethical, and sustainable supply for everyone. This affects the price of your next phone, the power in your home, and even global politics. Being aware of where our stuff comes from helps us make smarter choices. The story of these minerals is about science, innovation, and our shared future. They create super strong magnets, brilliant light, and clean energy. The Earth gives us these resources. It's our job to use them wisely. Next time you use your tech, remember the hidden powerhouses making it all possible.